Hello and welcome to UNL's Best Chemistry Podcast, Chem 101, with today's host, Valeria Salinas. Today, we're going to be talking about carbon-based compounds, aka organic chemistry. Now, carbon. Its chemical properties allow it to join with a large number of different atoms to form large and complex molecules. Its position in the periodic table tells us that its valence electrons are located in the fourth level. Its electronic configuration is 1s2, 2s2, 2px1, 2py1, 2pz0. And when in an excited state, an electron of 2s2 is transferred to the empty 2pz0 orbital, resulting in a new electronic configuration. This explains its tetravalence, which means that it can form covalent bonds with another 4 valence electrons. Carbon also has what is called concatenation, which in simpler words means the ability to form chains with other elements. When carbon-carbon bonds are formed with single bonds, that is, sharing a pair of electrons, we have the hybridization sp3, which means the sum of the orbital s with 3 p orbitals. When the bonds are formed with double bonds, aka sharing 2 pairs of electrons, its hybridization is sp2, meaning that the sum of orbital s with 2 p orbitals. And finally, triple bonds, sharing 3 pairs of electrons. They have sp1, meaning the sum of orbital s plus orbital p. These bonds can be expressed in 3 different ways, and even though they mean the same, this can sometimes make a difference. First, we have the molecular formula. This is the one that indicates the type and number of atoms that make up a molecule. Then, we have the developed formula, which is the most graphic way of representing it, and it shows every single bond between elements. Next, we have the semi-developed or condensed formula. This is the one that represents the bonds between carbon and grouping the hydrogens. This is the one that is more practical. Next, we have my coworker Ashley to explain in more detail carbon compounds.
Hello, my name is Ashley Almaguer. I'm going to talk about the topic 4.2 Organic Compounds, Carbon Compounds. The origin of the carbon compounds can be natural or synthetic. The former compounds are present in all living organisms and they are part of the biological substances. The type of organic compounds are carbohydrates, lipids, proteins, and nucleic acids. Organic compounds are those that have carbon. However, there are others that contain carbon such as carbides, cyanates, bicarbonates, carbonates, and carbon dioxide and dioxide, which cannot be considered organic because they don't contain structures with carbon-carbon bonds and also have properties different from those of organic compounds. Organic compounds have characteristics and properties, both physical and chemical, very different from the inorganic ones. Organic compounds. They contain carbon as the main element, almost always hydrogen, and often oxygen, nitrogen, sulfur, halogenous, and phosphorus. Inorganic compounds. They are made of combinations between the elements of the periodic table. They don't always contain carbon. Organic compounds. They are gases, liquids, or solids with low melting points. Inorganic compounds. In general, they are solids with high melting point. Organic compounds. Most are fuels. Inorganic compounds. They usually don't burn. Organic compounds. They decompose quickly by heat. Inorganic compounds. They resist high temperatures.
Hi, I hope that you are enjoying this podcast. And I'm Valeria Casillas, and I'm going to talk you about the topic general classification of organic compounds. And this classification can be in different ways depending on its origin, that is natural or synthetic, by its structure, that are aliphatic, alicycle, or aromatic, by its functionality, for example, alcohols or ketones, and finally by its molecular weight. And in this section, and we will base on their structural characteristics that can be two, that is the hydrocarbons and the hydrocarbon derivatives. And well, first I'm going to talk you a little bit about hydrocarbons, that are compounds formed only by carbon and hydrogen, and they also are classified into aliphatic, alicycle, and aromatic hydrocarbons. And first, I'm going to talk you about the aliphatic, that are the ones who open chain hydrocarbons. The aliphatic can be saturated or unsaturated, that is the alkynes. And the unsaturated hydrocarbons, we will find the alkenes, that is the double bond, and the alkanes with a triple bond between carbon and carbon. And they also exist the alicycle hydrocarbons, that is the carbon atoms form or a ring, and they can vary in the number of atoms in the cycle, and it can be also saturated. And here we find the cycloalkanes or unsaturated. And finally, there is aromatic hydrocarbons, that these receive their name because of the intense aroma that characterize them. And well, they are considered as Benz derivatives, since the cycle structure of Benz is present in almost all of them. And well, in general, they contain rings of 6 links in which single and double bonds alternate. So guys, I hope that you could understand and enjoy my information about this topic. And well, my friend Alex Angel will continue explaining a part of this topic. Thanks.
Thank you, Vale, for your collaboration to this topic. And now I'm going to talk to you about the derivatives of hydrocarbons. So I'm going to start by saying that they are compounds that in their structure, in addition to carbon and hydrogen, contain other elements. These elements make up the functional group of the molecule, and this is the most reactive part of the molecule. So first, among the derivatives of hydrocarbons are halogenated derivatives, which are organic compounds in which halogens replace one or more hydrogens of the hydrocarbon chain, such as fluorine, chlorine, bromine, and also alcohols. Another derivative is ethers, that are groups containing carbon atoms and the oxygen atom is linked to them. And last but not least, amines, that are hydrogen compounds that can be described as derivatives of the inorganic ammonia compound NH3, where one or more hydrogens have been replaced by alkyl or aryl groups. And well, I hope you understood. So now to the next topic, nomenclature of hydrocarbons. These, at the present, are compounds that are governed by a set of rules established by an international organization that groups two national chemistry associations around the world, and this is known as EUPAC. One of the nomenclature can be alkene nomenclature. Alkene, also called paraffinic or saturated hydrocarbons, are substances with stray or branched chains of carbon atoms, and among these atoms there are only single covalent bonds. All the carbon atoms in the alkene have sp3 hybridization. The first three members of this family do not present isomerism, so they can be represented with their molecule formula and be named in only one way: CH4, methane, C2H6, ethane, C3H8, propane. I hope you understood and enjoyed my explication. And now welcome my friend Majo. Thank you.
Your introduction, Alexa. Now I'm going to talk about the fourth member of the alkane nomenclature, which is butane. Isobutane is the simplest example of a branched chain. Branches or radicals are named with the root of the normal alkane from which they come. For example, CH3, called methyl, comes from methane, which differs in a hydrogen that loses by joining the chain to follow, conserving the tetravalence of the carbon. Some examples of the alkyl radicals are methyl, ethyl, propyl, and isopropyl. From the fifth member of the alkanes, the name is formed by prefixing the number of carbon atoms and the ending "ane", indicating that it is an alkane. These are methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. An interesting fact is that for each carbon atom that increases, two hydrogen atoms increase. For example, in propane, that is C3H8, you're gonna add one carbon atom and two hydrogen atoms, and it will be C4H10, meaning butane. And this is called an homologous series. Now I'm gonna talk about the nomenclature of the alkenes and alkynes. Alkenes and alkynes are also known as unsaturated aliphatic hydrocarbons, and these are characterized by the presence of double or triple bonds. Their names derive from the names of alkenes and only differ in the ending of the name of the main chain. The molecular formula for the alkenes are CnH2n, and for the alkynes, the molecular formula is CnH2n minus 2. The IUPAC rules for the naming of these molecules is that rule number 1, you must select and number the longest chain, starting with the carbon closest to the double or triple bond. The carbon number will give the base name to the compound. Rule number 2, you have to identify the radicals or the branches and their position in the chain. Rule number 3, the name is formed by first indicating the position of the radicals, name the radicals or substituents in alphabetical order, and then the number indicating the position of the unsaturation, and finally the name of the main chain. And give the "-ine" ending in case it's an alkene or the "-ine" if it refers to an alkyne.